Hello, everyone. This is my first time in Bristol, and I've barely been here 5 days, but the city has really grown on me, rain and all. So really big thank you to Oliver for giving me the opportunity to speak here. Now, I normally use slides in my talk, often as a means to supplement the ideas I'm trying to put forth, but there will be no slides today. Instead, I'll be using DevTools to illustrate the points that I'm trying to make. And how this talk even came about is rather accidental, to be honest. So basically what happened is that about late last year, a colleague of mine, good friend, fellow Mozilla tech speaker, Alex, was giving a talk about DevTools in a meetup. And he was like, hey, do you want to come? And I was like, yeah. And then, but do you want to give a talk? And I was like, no. But eventually, what happened was we settled on him ceding all the CSS-y bits to me while he talked about the JavaScript stuff. And because there was no time, I built a web page and talked through DevTools using that. And then at the end of it, Alex was like, hey, you know, that make a pretty interesting talk. And so here we are. Now, I learned a lot of cool things about DevTools from Alex. And one of the things that stood out to me was that the DevTools console can totally be styled up using CSS. But just like support of CSS on actual web pages kind of differs between browsers, this is also the case for CSS support in the browser console. So case in point, this is a really fancy CSS-only talk title in my console. And let's see how it looks like in Chrome. It's all right, I guess. And this is what it looks like in Safari. It's like, So I don't know, I think it looks way better in Firefox, so let's just switch back to that. Yeah, so my name is Hui Jing. Let me scroll this. My name is Hui Jing. I'm a developer advocate with Nexmo. Nexmo is a communications API for messaging, voice, authentication, and recently videos. And there's multiple of us in the audience, so come have a chat. I also have lots of stickers, so if stickers are your thing, you can come get some from me. I'm also an avid lover of emojis, and those pretty much sum up what I am as a person. If you're curious about any one of them, come ask me about that later as well. And finally, just to prove a point, just to prove that Firefox really does support the most CSS properties, it's the only one that does writing mode vertical. So it's like vertical writing in your console. I love it. Now, when I started building stuff on the web, I quickly realized that aligning stuff horizontally was way more straightforward than doing it vertically. And I started thinking about why that was. So historically, web technology started out from text document beginnings. And a lot of the initial HTML tags and CSS properties were focused around text formatting for languages that were mainly laid out horizontally from top to bottom, languages like English and French. Boxes on the web behaved very similarly. But ever since designers and developers realized that the web could be used for more than just academic paper-style layouts, they've been complaining about how hard it is to do layout on the web. And I don't blame them, because for a very long time, it was hard to lay out anything resembling those gorgeous designs that our print counterparts could achieve on posters, in magazines, and the like. But I do think that things are changing for the better. So when I refer to modern CSS layouts, I'm talking about layouts that are built with Flexbox, with grid, with the box alignment properties, because conceptually, these are properties that were crafted specially for doing layout on the web. And they're different from the prior techniques we've used to have, like HTML tables for layout, or even floats, because these were more clever uses of properties whose intended purpose was not layout to begin with. But resourceful developers, like yourselves, found plenty of workarounds and hacks to work with whatever features were available at the time. And these days, we have a much more robust tool set for doing layouts on the web. So the first thing that I want to cover today is content-based sizing. And I'm going to apologize in advance to the people sitting in the back. This is as much as it can zoom. I'll be mostly talking about DevTools, so I'll try to talk over whatever it is I'm showing. So sorry to the people at the back. So the concept of automatic sizing has always existed because browsers have always managed to figure out how much space content should take up without any intervention from us. Content would just reflow without overlapping, really good default feature. But what we have in a relatively recent CSS specification known as intrinsic and extrinsic sizing is that we now have the option, we as authors of web pages have the option of assigning automatic widths to the elements on our page. So the width and height sizing properties now can take in 3 additional keywords, which are min content, max content, and fit content. So this first set of items here, they're sized with min content, and it is the smallest size that a box could take that doesn't lead to overflow. So if you have inline content, they will break into multiple lines. Now, line breaking is a lot more complicated than what most people give it credit for because there is a lot of nuance involved depending on the language that you're using. One thing to note is that browsers will not break words, right? So in the first set, it's English. Again, I'm going to read it out. This is an English sentence, and the longest word here is content. And the browser will treat the word content with the full stop at the end as a single unbreakable entity. And that's what ends up being the width of this first box. But for languages like Chinese or Japanese, and this is a string of Chinese characters, the line breaks occur per character. So you end up with a width that is 1M because Chinese Han characters are square characters and every character is displayed within a box. Now, East Asian scripts also use something called full width punctuation. So if I add a comma right here, then the box becomes 2Ms instead of 1. So that's for Chinese, but then you also have certain Southeast Asian scripts like Thai, and now I'm not sure if anybody reads Thai in the audience, but if I bring your attention to this second line of content, it's exactly the same content as the first, except it's sized with something called max content. And max content is a box's ideal size on a given axis when it has infinite amount of space. So if there is no limit on the amount of space it can take up, the content will just take up as much space as is required to lay out the entire line without breaking. So if you notice this Thai sentence, again, sorry to those at the back, Thai is a language that is written without spaces between words. So if you don't read Thai, I guess you wouldn't know whether this is a word, a sentence, a phrase, but the browser does. The browser's pretty smart. So the longest word in this Thai sentence is actually this second word. It's called prayok, and that ends up being the width of the box, and that's how it works. Now, fit content, which is the third keyword, is unfortunately an unsupported value at the moment. So come down here, and what you can see in the DevTools, it will kindly tell you, oh hey, invalid property value, but that's fine, it's all right. Fit content is not a fixed value like the previous 2 keywords. It is a range. And it is a range between the min content value and the max content size, or the length percentage defined in the function. That was a mouthful, so it makes more sense if I explain it. Now, but even though it's not recognized as a width, it works if you put it in a grid formatting context. So this is relevant. So right now, what we have here is three sets of content, 3 different languages. The content within the second and third are exactly the same. It's exactly the same Chinese characters in all 3. And you can see we've gone through min content, so that's why it looks like this. We understand what max content is. What fit content is a range. So let's make this smaller. I'm going to resize this. Go. So as it goes, as it shrinks, it's going to hit the min content width. So it matches. The first and third match. That's the minimum width, min content. But as it grows, as there's more space, it grows, but it stops. It doesn't reach its max content width because of the 300 that we've put inside. Because of this 300 we put inside fit content. So that is the cap. So the browser is going to take the smaller of the value, max content, or the cap. So if I change the cap to something longer, say 500, and then I grow the browser some more, it grows, and this length of content is not 500 pixels, and neither is this. This is about 400-ish, but the browser's not going to expand to 500 because that is the smaller of the value. So that's the point I'm trying to make. It's really tiny. You can't see. I'm going to trust me when I say it's 462 pixels wide. So that's how bit content works. So the next part that I want to cover is Flexbox. Flexbox, or it's known as the layout model where nobody knows the exact size of anything. So, but hopefully I can help shed some light on this apparent mystery. And right now, Firefox is the only browser with a Flexbox inspector. So that's why I think that Firefox really shines in this regard, especially if you are using Flexbox in a lot of your work. So how we can toggle it, there's several ways to toggle this. So if you're in the inspector, you can see there's this tag, and you can click on it to toggle the overlay. What's helpful is that it tells you what Flex actually does. It's a recent development, so that's kind of fun. You could also go to, at the rules panel, there's this like two square icon thing. I mean, designing icons is hard, so you can toggle it from there as well. One more place is the layouts panel from Firefox, where you can just click on this big old toggle thing. And what this Flexbox inspector does is, yes, it gives you an outline of each of your Flex items. And if you've got any free space, there's this bit of a texture here to tell you that the Flex container is that big. There's free space. If you look at the layout bit, it'll tell you the Flex direction. Here it says row. It'll tell you the wrap status. Here it says no wrap. But more importantly, it tells you what the browser does to your Flex items when you apply a display Flex on the parent container. And I'll explain this in more detail in the upcoming examples. One thing to note when we use Flexbox is that the specification recommends that we use keywords for the Flex items because they cover the most common use cases. And these keywords are initial, which is actually the default value. If you applied a display Flex on a parent container and nothing else on the children, the browser recognizes it as Flex initial. Then you also got none, which makes your Flex items completely inflexible. You've got auto, and you can put in a single positive integer, and this will be resolved to Flex grow. Now, I say resolved because the browser understands numbers. So when we put in a keyword value, the browser does some things to it, and we can actually see how the browser resolves these English words into numbers by going to the Computed tab. And you can activate browser starts, because these are things that we didn't explicitly write. The browser did it. Oh boy. No. Come on. Seriously. I'm sorry. If you can't see at the back, very exciting things happen. There's a spinning beach ball of death. I'm going to give it 5 seconds, and then I'm going to restart my computer. I'm sorry. 2. Nope. This has happened. Oh man, I should have restarted my browser before I came this morning. And off. All right, let's go.
Oh, this is looking good.
It's going.
It's looking good. What do you reckon?
Turn it on.
Yeah. Okay, a giant round of applause, please, as we get back up again.
So sorry. Thank you, Phil. I'll buy you a drink later. Thanks for saving. So where was I? Okay. Flex items, right? So I'm just going to toggle this back on. Please don't give me another spinning beach ball of death. Otherwise, we'll have something to say to the IT department where I work. So anyways, back to this. So it seems that the sizing of Flex items depends on a number of factors. There's like the amount of free space available, there's the amount of content within the Flex item, and the starting width of the Flex item. The exact algorithm to calculate the size of an item that has been sort of tweaked with by the browser is a bit complicated, but it is outlined in the specification if you're interested. Now, I think things get a bit clearer in terms of understanding how Flex works once we all get a better understanding of what Flex basis actually is. So if I put a fixed value of 100 pixels as a flex basis value on a flex item, it's not surprising that some people are going to expect, well, I put 100 pixels there, the item ought to be 100 pixels. But that's because we're very used to having control over our sizing instructions, not so much when we start using something like Flexbox. Flex basis is actually the starting point from which the size of the item is being calculated. So the keyword here, it's the starting point. Because if your flex item is allowed to grow or shrink, odds are your ending final size is not going to be 100 pixels. So now let's move on to this second example. Still working, yes. So I have two sets of items here. They have 3 flex items each. So the first 2 items got exactly the same content. The first item has the word word in it, very meta. The second one says, this is a sentence. And the third one is some other random content. So just to have a contrast, there's more content in the second set. Now, both of these have display flex on the parent and nothing else on the children, which means that the flex items are all flex initial that resolve to the values of 0, 1, and auto. To have a flex grow value of 0 means that the item's not going to grow even though there's an infinite amount of space. So if I go up to here, there's all this extra space. The items are like, no, I'm good where I am, not going to grow there. But there is a flex value of shrink, which is set to 1. So all of the flex items are going to start shrinking at the same rate the moment there isn't enough free space. So to explain the situation of why, even though there's exactly the same content in the first and second, if there is not enough free space, just now we were at this point, you notice that, oh, hey, this is a sentence is distributed differently for the first and the second. And why that is because of the impact of having a lot of content in the third. So the moment I hit this particular point, there's not enough space. Both this is a sentence and the really long line is going to start shrinking. So that's why by the time we get to this point, this is a sentence on the second set has already done a considerable amount of shrinking. But the one on the first, like, no, I'm fine. I don't need to shrink at all. So that's the reason why these two, even though it's exactly the same content, different size. Now, a flex basis of auto, again, a reminder, let's see, this is sort of a legend. So flex initial resolves to a flex growth factor of 0, shrink 1, and the basis is auto. So when there is a flex basis of auto and the width of the flex items, I'm going to go back, oh boy, what is this? The width of the Nexmo is great. We have a fantastic IT department, just saying, you know. So if we go back to these flex items, I've not set an explicit width. If you look at the rules, it's just a simple border. There's no sizing involved, so which means that the width of my items are auto, the flex basis is also auto. So in this scenario, what the browser is going to do is say, okay, flex basis will be content. And what content is that it is an automatic width that's determined by the content that's contained within your flex item. So we can see this if we go to the Layout tab. So this is really, really useful. You select the box, and it tells you the content size, which is, in this case, I'm going to read it out, it's 211. I'm just going to ignore the decimal points. So I'm going to highlight this one, and we can see, okay, it's 934. That is the actual content size, but because there isn't enough space, I've shrunk it. So at this point, the DevTools is going to tell you that, oh, we did something. We did something to your item. We shrunk it. It says the item was set to shrink, and it shrank by 348 pixels. That is why you have an ending size of about 586. The moment that I saw these numbers, it started to make sense to me. So that's auto, but now there's sort of a hierarchy of what the starting size should be. So when I come to this particular, I've highlighted this particular box, and I'm going to give it an explicit width of, say, 200 pixels. In that case, the starting size now becomes 200 pixels. So then the browser starts calculating from 200. So because the flex grow for this specific use case is 0, the ending size does end up to be 200. So there is a case for this. But when there's a width, if there's also a flex basis, so now I'm going to do a flex basis of, so 0, 1. Let's set the flex basis to 300 pixels. Oh, what happened? Flex. Oh, sorry, flex shorthand. So this means that the flex basis is 300, and now the flex basis is, it trumps the width. So if you go back to the flex inspector, it tells you now that the starting size is 300. So that's the sort of hierarchy of starting sizes. Now, if I do some more browser resizing, because clearly this is what we do in our day jobs, resize the browser. Now, if I start shrinking, again, first and second are going to start shrinking the moment there isn't enough space. It will continue to shrink until it hits its minimum content, and then everyone else starts to shrink. But the point here is that at the end of the day, min content will end up being the same because the content in the first and the second sets of items are exactly the same. Now for the next example down here, I want to cover the difference between having a flex basis of auto and a flex basis of 0. So again, two sets of items. This time they have exactly the same content. The content matches top and bottom. Now both the items are allowed to grow and shrink. As compared to the first one, we didn't allow them to grow. This one, it's allowed to grow. So the flex shrink is kept to 1 to make things easier to observe, but these three flex items have different grow factors. So for the first one, I've set it for a grow factor of 1. The second one is a growth factor of 2. And the last one, like no growth factor, 0. The only difference is that this first set has a flex basis of auto, second one, flex basis of 0. And you can see distinctly different end results. So the available free space in the first set of content is actually the total width of the container. At this point, it's this total width minus the widths of the content within all three items. So if you can see my cursor, this bit here and this bit there, that's all the free space that it is, because the content widths are not considered free space. So if we go to the Layout tab, I'm going to highlight this. It'll tell you that, okay, there was a lot of free space. The item was set to grow. How much growth, you ask? 113 pixels. Now, if I compare this with its adjacent item, which was set to grow at a growth rate of 2, the browser will tell you, yes, indeed, I have grown it twice by 226. The numbers actually do match up. But keep in mind that it's the amount of growth that was allocated. So if you look at the content on the page itself, you'll notice that this first item is not half of the second item. It's not as if the second item is twice the width of the first. If you did want a scenario, if you did want an end effect of that, what you would have to do is to have a flex basis of 0. And this makes sense if we examine it. So the second set does have a flex basis of 0. Now, if we look back at the inspector, it's going to tell you content size is 0 because we set it, ignore the content. So the amount of free space in this second scenario becomes the total width of the container minus this bit at the end, because this content size still has to be respected. So the amount of free space that the browser can now give out to the items that are set to grow is all of this. All of this is free space that can grow. So if you look, it says the flexibility was set to grow like all of it. So its final size is 356. And if we look at the second one, it's 712. So that is really exactly twice. So if this is a particular sort of end result that you need from your flex items, you'd want to use a flex basis of 0. I think that's the difference. And if we understand this, it stops being so confusing, because a lot of times I think we set it to auto and we're like, it's not double. I don't understand why. I made it grow twice. So that's pretty much the reason why. And next bit is going to be aligning flex items. Now, being able to align items, I think, is a big plus with the newer CSS layout properties. And these are defined in the box alignment properties. And the Flexbox inspector does allow us to visualize the free space in which your flex items can maneuver around. So I'm going to go back here and toggle the overlay. So you can see outlines of your flex items and all the free space that you get to play with. Box alignment properties were actually meant to be used across layout models, meaning block, flex, grid, all these formatting models. But for now, they can only be used with flex and grid. Now, my trick for remembering which properties apply to which axes is that my brain associates the word justify with, text editing software or WYSIWYG softwares, and they've got these 4 icons at the top that let you align text, justify text, left, center, right. So in my brain, it's like, as long as it's the direction that text flows, that's justify. And because we only have 2 options, the other word is align. Naturally, it means the opposite, which is like the vertical. So that's the trick that I use to remember. Don't know if it helps you. When using Flexbox, there are a total of 6 box alignment properties, but only 4 are available for Flexbox. Justify items and justify self don't actually do anything if you put them on a flex formatting context. Kind of a nifty new feature. I'm using Firefox nightly, so maybe that's why I had a spinning beach ball of death. I don't know. Please don't sue me. But if we set like a justify items value, which is not valid, right? And it's really blur. But there's this eye icon, and if you hover over it, the browser's DevTools is going to explain to you why it's not working. So that's relatively new. So if you've got a copy of Nightly, you can give it a try. It's on by default in Nightly. So anyway, justify items doesn't work. What does work is justify content. So justify content lets us adjust flex items along the main axis. So if I switch this to center, I switch this to end, these are positional keywords that allow us to move all the flex children along the main axis. But you've also got a set of keywords that start with space, and these are distribution keywords. So you can see that what they do is distribute the free space between the flex items. Now, these flex items, they are stretched by default to the full height of the flex line. So let's say let's say the container, is much higher. So say like 90 VH. It's still stretched. But the moment I apply a value of like align items, say maybe start, the items revert back to that's their original width. That's how they're supposed to look like. They're supposed to be sized. But then you get these annoying little gaps here that you may not want in your layout. So what we could do is we can pack these lines together with align content. So if I do like end, it's going to squish all your lines back together. This is free space. That's fine. You can sort of centralize it as well. What is one of the more interesting values for align items, though, is this value called baseline. So I'm just going to get rid of these so it looks clearer. So without baseline, you'll see that the content within my flex items is sort of like it's mountainous. It's pretty hard to read. If you had a design whereby you wanted the text in your flex items to be related, maybe it could be a sentence. This is kind of hard to read. So if you trigger baseline, what it does is it aligns the text within each of your differently sized flex items along a line. So if that was a design scenario you had in mind, this particular value might be helpful. Now, if we move on to some real-world use cases for Flex, this is actually my favorite use case, which is auto margins. Auto margins are your friend. So unlike the current implementation in block formatting context, using margin auto will actually center your item right smack in the middle of your container. Don't have to worry about anything else, because what it does in a flex formatting context is equal amount of space on the top and the bottom, equal amount of space on the left and the right. So even if I had multiple items, let me just duplicate box here, duplicate. In this case, and if I highlight it, you'll see that it is, again, equal amounts of space for that particular item, top, bottom, left, and right. So if you only had one item inside your Flex container and you needed it centered, instead of using the box alignment properties, you could just slap on a margin auto on the item and call it a day. One thing to note is that if free space has already been distributed to auto margins, if you apply alignment properties on top of that, they're not going to have an effect because all the margins have already stolen all the free space left after flexing. And a relatively common use case for these auto margins is this navigation bar, where you sometimes have one lonely end link that's supposed to be all over on the other side of your navigation bar. What we could do, make use of auto margins. We set a margin left of auto, kick it to the side, and you can also take advantage of the box alignment properties to get everything center aligned, which is something that has been quite tricky in the past, but now it's gotten much better. And the last use case is for card-based layouts, because they are oh so popular these days. The point I want to make here is that feel free to change the flex direction when necessary, because yes, the default is row, which is sort of horizontal in most cases. But if you can see here, if I set the flex direction to column, I get the advantage of being able to push this. And this is so common that it's a bit low. But you'll see that you have a card, and then there's some random call to action at the bottom, and you need the call to action to kiss the bottom of your card, but you've got content that's not the same height. What you could do is you could just make your main content grow. So once I do a flex of 1, the call to action just gets pushed to the bottom. So it's like a 2-line sort of solution for this very common use case. It is very basic because there's going to be an use case where you have call to actions of varying heights. And that's why you need to pay a lot of attention when Rachel covers her talk on subgrid in the afternoon, because subgrid is the perfect solution for that particular use case. I'm running out of time, so I'm going to move on to something called flexible sizing. Just out of curiosity, has anybody actually used grid or played with grid, knows what it does? That's brilliant, that's great. But whether or not you're just starting out with grid, or if you're already even using it in production, Firefox still has the best grid inspector at the moment. And again, there are multiple ways you can toggle the overlay. I might start speaking a bit faster, so I apologize. So what we can do now is you can still do this, toggle it from the inspector. You can do it from the rules. Click on this nice little waffle icon, which is much better than the Flexbox icon. You can go to the layout panel, where you can select the grid of your choice that you want to see the overlay for. Recently, Firefox started supporting, oh hey, multiple grid overlays, which is great if you're using multiple grids on the same page like me, or if you're doing nested grids and you want to check alignment. That's actually very useful. You can actually change the color of the overlay. I think the defaults look pretty, so that's fine. And you have options. You can extend grid lines or not. It's not very clear. I apologize. But all these tools are very useful if you're using grid for like the whole page layout, or even just components that you want lined up, but they're far away from each other. So that's the grid inspector. But the point what I want to cover here is specifically on flexible sizing. So we're going to do a comparison of what these different flexible sizing units can do. So previously, we've always used relative units like percentages, or even the newer viewport units. But the limitations with those units is that they make your elements change size at the same rate. So I'm going to show you an example of this. So this is sized using percentages. So the image is 65%. The main content is 35%. The problem with this sort of sizing is that it works best like at this point, maybe, and maybe around from here to here, it's kind of okay. But the moment you give it more space, like, oh my God, the cat's too big. Or if you go very small, you're like, the cat's too small. Oh no, it's out of the page. So we end up as developers or designers is that you end up writing a lot of media queries to cater for this, because this constant same rate of change, I feel, is very limiting. But what's interesting about the newer CSS properties is that you can have variable rates of change. So Grid introduces this thing called an FR unit, which is a fraction of free space available. We also have a min-max function when we use the grid formatting context. It's a range value, which is really fun. Together with other intrinsic sizing values that we've covered earlier, like fit content, and then we've got the age-old auto, this whole set of sizing units gives us the ability to have variable rates of change. So again, there's going to be a lot of browser resizing coming up. So this is like your day job at a conference, I'm sorry. So FR versus auto, right? So this is a legend, so you don't get confused. FR is in green and auto is in blue. So whenever there's any extra space at all, FR is the greediest size value. It'll take all of it. It'll absorb all of it. So if you see when they're combined together, FR and auto, FR always takes most of the space. That's fine. If there's no FR size column present, auto is like, fine, I'll take the free space. I'll grow to all available space. I'll take it. But if FR is present, I'll be fine. FR, you do your thing. They'll stay in their own lane. But when there isn't enough space, because even though FR gets all the space when there's a lot of it, it's also the first to get space taken away from it, right? So when there's not enough space, the FR column is going to shrink first. It's not only going to shrink, it's going to shrink until there's nothing left. It will shrink till the minimum content size, but you'll notice that auto keeps the max content width for as long as it possibly can. I'm referring to example 3 right now, the third one. Do you like boxes keeps its width all the way until all the space has been taken away from FR before it starts shrinking. Of course, at the end of the day, all of them end up with min content, but there is a difference in the behavior when they're interacting with each other. And the next set I want to compare is actually fit content with min content. So fit content is the orange bit, min content is the yellow bit. Both of these sizing values, let's say, they behave similarly in that they're both a range, and they range with a maximum and a minimum limit. So min-max will take in 2 arguments. The first one is the minimum size you allow it to shrink to, while the second argument is the maximum size you allow it to grow to. Then it can maneuver within the space you've given it. When there isn't enough space, FR takes everything, so that's pretty obvious in the first one. But if you look at blue and orange, which is auto and fit content, you'll notice that the moment FR gets all its space taken away, auto and fit content, boom, they behave similarly. They shrink at the same rate. They hit the minimum size at the same rate. But when there's lots of space, auto, if we look at the second one, auto will take up the free space. So now let's move on to the second example. This is now a min content, an auto, and then a fit content. So without FR present, auto takes over that absorption of free space. That's fine. It also gives up all the free space. And the moment it hits its max content, it actually stops shrinking. It doesn't shrink anymore. What happens is that the yellow bit, the yellow column, starts shrinking. So it will shrink. It will continue to shrink for a while. But then you notice at some middle ground, everyone starts shrinking again. Now, exactly what this point is, I can't really tell you. But this is because they are coordinating themselves, all 3 of these columns, they're coordinating themselves to reach their minimum size at the same time. So if we continue to shrink, we now know that the yellow column's minimum size is 200. For the blue and the orange, it's the min content size. So they will all shrink and hit their minimum size at the same time. And conversely, when space is given to it, so look at the blue one. The blue column will grow together with the yellow column because there's space. Both of them are growing, having a good time. The moment it hits its max content, they stop. The blue column stops growing and says, hey, min-max column, go ahead, do your thing until you reach your maximum size before it takes over again. So I think this particular behavior it's a new, right? And we haven't really got our heads around to that this is a thing. But I think what it does is that it gives us a lot more options for, say, editorial design that adapts better to a wider range of viewport sizes. So I've got a very basic example here. It could be a header for a feature article, for example. And these are two different examples. They look very similar at a large viewport. But if I shrink it, you'll start to notice the same problem as the cat for the first one, where like at the smaller viewport, it's like, the image is too small, the text looks funky. But if I use, and let's just close this one, which is sized with the variable sizing units, it performs much better at the extreme viewports. And I've not had to do media queries for this. It just behaves as it is. One good thing about grid is also it allows us to do overlap very, very easily with positioning values. So this is just something to consider, especially if you're doing editorial style design and your designers are complaining that the designs are so boring. You're like, no, you've got options now. You've got options to be creative at very different viewport sizes. And I've ran out of time because I had to restart my computer. So I'm just going to wrap up by saying that I'm really, really excited for all of this to become mainstream and to have more designers and developers start considering these possibilities in their designs. So if any of you are still a bit on the fence, like, I don't want to use Flexbox, I don't want to use grid, no, just do it. Thank you very much.